Welcome to Ask and Learn.
So we're given this function to model concentration over time, and we're given these constraints. A, B, and K are positive constants, and B is greater than K. So I just picked these random numbers that do work for these constraints, and I plugged them into the function, and I got this function. So if we want to graph it, the first thing I'm going to look at is the first derivative. So C of t, C prime of t, so the first derivative, is going to be negative e to the power of negative t plus 2e to the negative 2t. Okay, and I'm going to set this equal to 0 to find my critical points. And I see that t is equal to ln of 2. All right, so ln of 2 is approximately 0.693. So if we test values, so this is ln 2. If we test values into our first derivative, for the first derivative test, for less than ln 2, we're going to see that it's increasing, and anything greater than is going to be decreasing. So it's a local max. All right, so this can be useful for later. And then C double prime, to look at concavity, C double prime of t, we're going to get e to the negative t minus 4e to the negative 2t. If we set that equal to 0, we're going to see t equals 2 ln 2, which is approximately 1.39. And if we do the second derivative test, so f double prime, and we test values around 1.39, we see that it's going to be concave down and then concave up. So this is an inflection point. All right, so we're going to use this while we graph in just a moment. But I'm going to look at one more thing, because our graph actually does have an asymptote. It has a horizontal asymptote. So let's test the limit as our variable t approaches infinity of our function, which is 1 times e to the negative 1t minus e to the negative 2t. All right, and we're gonna, so let's just say that we do the limit as t approaches infinity. I'm gonna rewrite this in a way that looks easier to understand. So this is the same thing as 1 over e to the t, because it's a negative exponent, we bring it to the denominator. So 1 over e to the t minus 1 over e to the 2t. So this is the same thing. All right, and if you take a look at this, it's and we substitute wherever we see t's, we're gonna substitute infinity. So as t approaches infinity, we see that 1 over a very large number is close to 0. So this is gonna approach 0. So as t approaches infinity, our y values, which is concentration over time, is gonna approach 0. So we have a horizontal asymptote at 0. Okay, and now we can graph. And since we're looking at time, I'm just gonna show the positive part of this, because negative time doesn't really make sense to me. So this is concentration over time for this axis, and this is just time over here. And we know that we do have, so let's say this is approximately 1. We know we have a maximum at ln 2, and if you plug in ln 2 into the original function, you'll see that it's equal to a fourth. So we know that about ln 2 and 1/4 is our maximum, and this is just a rough sketch. So I'm going to say this is ln 2 1/4 at this point, and this is our maximum. Okay, and we see that according to the second derivative test, that it's going to be concave down and then concave up, and our inflection point is 1.39. So that's where we're going to see the sign change at about 1.39. So let's say it's right there. Okay, so it's going to be concave down. Oh, and we also haven't, don't forget about the asymptote. The horizontal asymptote is right here. Okay, so we have concave down. It's gonna, first of all, increase until it hits our maximum, local maximum, and then it's gonna start to decrease after it hits the max, but it's still gonna be concave down until it hits our inflection point where it's gonna be concave up and approach but never touch our asymptote. And this is our graph. All right, so this is our graph for concentration over time. And the question asks us what's happening in this graph. So we see as time is increasing, so as time goes on, concentration increases until we hit the, so as time goes on, concentration increases until we hit the maximum concentration. And then after that, the concentration continues to decrease forever.